So we want to prove that the ring R is local, meaning it has a unique maximal ideal, if and only if the Jacobson radical, which we denote by JR, and as you remember, this is the intersection of all maximal ideals of R, if and only if this Jacobson radical is itself maximal. Proof? Well, actually the proof is rather easy. You might see a formulation like it's easy to see or something like that in some books, but I think it's good to spell it out one time. Let's start by assuming that R is a local ring. So R is local. So R has a unique maximal ideal by definition. And by definition of the Jacobson radical, this means that the Jacobson radical, which is the intersection of all maximal ideals, is just this unique maximal ideal. So J of R is the unique maximal ideal. And well, of course, this shows that it is a maximal ideal. So this was one direction. Let's look at the other one. Now we have to assume that the Jacobson radical is maximal. And we want to conclude that R is local. For this, we just need to use the maximality of the Jacobson radical now. Because by definition, being the intersection of all maximal ideals, the Jacobson radical is in every maximal ideal. So the Jacobson radical is in every maximal ideal. But being a maximal ideal itself, it cannot be a subset of a maximal ideal bigger than itself. So this means that the Jacobson radical has to be the only maximal ideal. And this concludes the proof.